Good evening, dear student. So, once again, today we are revising our last lesson for test or for PA1 examination, and our last lesson is lesson number 3, and you can also say chapter number 3, factors and multiples. Okay, so we will revise this chapter in this video. Okay. So first of all, we are as you can see the chapter name. Our chapter name is factors and multiples. So in this chapter, what we will do, we will learn about factors and multiples. Okay. Also, you will learn in this chapter about LCM, which is lowest common multiple, and SCF, highest common factor. Some of you were having some problems in SCF and LCM, so in this video we will sort out your problem in this video, so carefully watch the video till the end. Okay, so now we are starting from factors. So see here, what are factors? We can take short definition of a factor. Here you can see here short definition of a factors are given. You can read it or you can learn it also, so it will be beneficial for your future. Okay, what is factor? A factor is a number that divides another number exactly, leaving no remainder. Okay, so it is a short definition of a factors. So first of all, now we will find out the factors of 12. Sorry. So what are the factors of 12? Those number which can divide 12 exactly, okay, completely, leaving no remainder, those will be a factors of 12. So we can say first of all how you will write 12. So you can write 12 as 1 into 12. So in Hindi you can say also the factors of 12 are those number in which table you can get 12. Okay, all those numbers. So here you will get 12 by 2 into 6. So after that you can get 12 3 into 4. So now just see the pattern. Okay, how you are getting 12 here. 12 1 is 12 and 12 6 is also 12 and 3 4 is 12. Okay, so this table. Now we can take numbers 1 2 3 4 6 and 12 itself. So these numbers are the factors of 12. Okay, 12 and 1, 12 will also be a factor of a 12. Okay, because 12 can come in a table of a 12, because 12 1 is 12. So 1 2 3 4 6 12 are the factors of 12. Okay, so in Hindi I am saying one line, just remember it. ऐसा कोई भी नंबर जिसके टेबल में 12 आ जाए वो सभी फैक्टर्स होंगे किसके 12 के. ओके, so this definition will be used for all the numbers for remaining the factors. Okay, so here what will be the factors of 12? You can write here like this way: 1 2 3 4, those numbers which I have circled. Okay, after 4 it is 6 and after 6 it is 12. So these are the factors of 12. Okay, so I hope that it is clear to you. Now we are going for multiples. I think you are already familiar with multiples. You already know about multiples. What are the multiples? See here multiples. First of all, we will read its definition here. This one. A multiple is the product of a number and any other whole number. You can read its definition or you can learn it also. Okay, so whenever somebody or anybody will ask you about what are the multiples, you can say that a multiple is the product of a number and any other whole number. Okay, now we are taking one counter example for multiples. Okay, so I am taking a number 7. So what you will do, you will only write a table of a 12. Okay, so you will get the multiples of 7. So 7 2 is 14 and 7 3 is 21, and like this way you will get 28 and 35 and after that 42. So these are the multiples of 7. 7 14 21 28 35 and 42. These all are the multiples of 7. So multiples are easy. What you will do, you will only read a table of any number, you will get the multiples of that number. Okay, or that digit. So now we are moving on prime and composite numbers. So after that we are moving to prime and composite number. What are prime numbers and what are composite numbers? So its short definition is given here. Prime numbers are the numbers which have exactly two factors, one and itself. Okay, so we will take one number, that is 7. Okay, so we can say we can see here that 7 is divisible by 1 and 7, so it is a prime number. Okay, in हिंदी you can say that 7 सिर्फ 1 और 7 से डिवाइड हो सकता है. Okay, so it is a prime number. We can take more example of a primes that are here 3 is also prime and 5 is also prime. After that 11 is also prime and 13 is also prime. After that 17 is also prime and 19 is also prime. Okay, because these numbers have only two factors, 1 and itself. These numbers can be divided by only 1 and the number itself. As 7, you can divide 7 by 1, you will get 7, and also you can divide by 7. So okay, you will get 1. So these are the prime numbers. Prime numbers are the numbers which have exactly two factors, 1 and itself. You can learn this definition from here. Okay, now move on to composite numbers. So composite numbers are the numbers which have more than two factors. Okay, so now we are taking one example of a composite number. What is composite number? So just see here 8. Okay, you can divide 8 by 1 2 and 4 and comma 8. Also you can say 8 can easily come in the table of these four numbers. Okay, so it is a composite number. Its short definition is that it has more than two factors. Okay, more than two factors. Here factors of 8 are 1 2 4 and 8. You can see here there are four factors of a 8, so it is a composite number. Okay, and what are the other example of a composite number? So we can say here as 4. Okay, and 6. After 8 has already come, and after that 10 and after that 12. Number which can be divided by more than two numbers are the composite number. Okay, so these are the composite number because they have they have more than two factors. Okay, so now move on to next concept. Now, divisibility rules. Divisibility rules means the numbers which you can divide by 2, 3 and 5. Suppose that you are given a number 1, 2 and 6, and I am asking you that is it divisible by 2? So by seeing the last digit you can easily say yes, it is divisible by 2 because it is a even number. Okay, numbers which are even uh, in a ones place, if even number is given, so that number will be exactly divisible by 2. Okay, so in 126 ones place digit is 6, which is a even number, so it can easily be divided by 2, so it is divisible by 2. And for example, we can also say if you are seeing on a ones place 0 comma 2 comma 4 comma 6 and comma 8, if you are seeing these 5 digit in the last or on a ones place, so those number will be divisible by 2. Okay, exactly divisible by 2. It means that they will leave no remainder when you will divide them by 2. Okay, so it is a divisibility rule by 2. I am showing you division also here, as we have taken example of 126 and you are dividing 126 by 2. So here you can divide it exactly like this way. So your 2 3 is 6, so your remainder will be 0. Okay, and quotient is 63, so it means that 2 has divided 126 exactly, it is leaving no remainder here, and quotient is 63, so 126 is completely divisible by 2. Okay, so same way we will also do this thing by 3. Divisibility rules of a 3. What is the divisibility rules of a 3? It means that how will you check any number that it is divisible by 3 or not completely divisible. So I am also taking one example here, 126. You need to check is it divisible by 3 or not. Okay, in हिंदी you can say that क्या ये 3 से पूरा पूरा कट सकता है कि नहीं. Okay, so here what you will do, you will add these three number 1 plus 2 plus 6 and you are getting 9, and 9 is in a table of a 3. 3 into 3 is 9, so it means that 126 is completely divisible by 3. Okay, so what you will do, if you will be given any digit like this way, I have given you 126, you will add these digit. Okay, single, and if you are getting the sum which is divisible by 3 or which is in a table of a 3, so it means that your number, your given number is divisible by 3, otherwise not. Okay, if here you are getting the sum which is not in a table of a 3, okay, or which is not divisible by 3, so that means it means that the number given will not be divisible by 3. Okay, I am taking one more example for explaining you the divisibility rule of a 3. and that is 125. Okay, now add 125, 1 plus 2 plus 5, single digit, and you will get 5, 4, 2, 7 and 1 8. So 8 doesn't come in a table of a 3. Okay, you are not getting it in a table of a 8, so it means that 125 is not divisible by 3. Okay, and you can also check it like this way. You will write here 125. Now check this, 3 4 is 12. You will get here 0 0, and now you get 5, and 3 1 is 3, and 5 minus is, so here remainder you are getting 2, and the divisibility rules condition is that you will get remainder 0, but here you are getting 2, so it means that 125 is not completely divisible by 3. Okay, so it is a proof of a divisibility rule. Okay, and adding these digits single and getting the sum and checking is it divisible by 3 or not, it is a shortcut trick. Okay, you will do in exam by shortcut trick also. Now in the end, one more divisibility rule is given in your course, and which is a divisibility rule of a 5. Now you will check any number, is it divisible by 5 or not. Okay, so for the divisibility of a 5, what you will do, you will just see the last digit of any number. If in the last of any number 0 or 5 is given, then that number will be divisible by 5 completely. Okay, like in a way I am taking 125 and I am asking you, is it divisible by 5 or not. So in the end you can see here the ones place digit is 5. So what 5 divisibility rule says, it says that if any number on ones place is 0 and 5, so it will be divisible by 5. So here 125, ones place digit is 5, which is divisible by 5, so 125 will be divisible by 5. Okay, it can be completely divided by 5, leaving no remainder. Okay, so we will check it here, is it right or wrong. So you will divide 125 by 5. Okay, so 5 2 is 10. Now you got 2 here and here 5. Now 5 25 5 is 25, so here you will get 0, so no remainder, and quotient is 25. So it means that 125 is completely divisible by 5. Okay, so also we can take one more example like this way. Say 1 2 0. Okay, because 0 is also coming, so you can divide from 5. 5 2 is 10, then 12 minus 10 is 2, and 0 will be here, and 5 4 is 20. So you got here 24 quotient and no remainder, so it means that 120 is completely divisible by 5. Okay, in last ones place digit you can see here 0 is given. Okay, so it is satisfying the condition. Digits numbers which are ends with 0 or 5 will be completely divisible by 5. Okay, now move on to next topic, which is SCF. Now move on to final two topics of this chapter, which is SCF and LCM. So HCF means highest common factor. Okay, see here definition highest common factor. So I am taking an example of HCF. Okay, so highest common factor means you will be given two numbers. For example, you are given here 8 and 12 and you need to find out the HCF of these two numbers. Okay, HCF means highest common factor which are coming in these two numbers. Okay, so first of all you will write the factors of 8 and 12. Okay, I have already told you about factors. So what are the factors of 8? The factors of 8 will be those all the numbers which can completely divide 8. Okay, so 1 2 4 and 8 will be a factors of 8. Also of 12, 1 comma 2 comma 3 comma 4 comma 6, and after 6 it is 12. So these are the factors of 12. Now you will see here what are the common factors. What are the common factors in these two? We will circle them. So you can see here 1 1 2 2 4 4. Okay, only these three numbers are the common factors of 8 and 12. So you will write here 1 comma 2 comma 4. Okay, these are the common factors of 8 and 12. Okay, so in common factors of 8 and 12, 1 2 and 4, these are the common factors. You can clearly see here 4 is the highest. Okay, so you need to find out the highest. So now you will write here highest common factor of 12 8 and 12 is 4. So 4 is your SCF and 4 is your answer. So any of the question will be given to you, you will do like this way. First of all, what you will do, you will list all the factors of a numbers one by one. Okay, separately like this way. Here you have written, I have written the factors of 8 and 12. Okay, so you will write like this way. After that you will circle the common factors just like we have circled. Okay, so common factors we have got 1 2 and 4, and what is the highest of it? 4 is the highest, so 4 is the SCF of these two numbers. Okay, so I hope that it is clear to you. If it is still not clear to you, you can comment below on a video or separately to me. Then I will also make one more separate video on SCF and LCM. Okay, now we are moving for LCM. Here in SCF you will only first find out the factors of the given two number, and after that you will write common factor and you will see what is the highest of common factors. That will be your highest common factor. Now last topic of this chapter is least common multiple, which is LCM. Okay, so for least common multiples we are taking one example of a two number 3 and 4, and we will find its least common multiple. Now 3 and 4. So you will write here the table of a 3, 6, 9, 12, and after that 15. Okay, now same way write a table of a 4, 8, 12, 16. Okay, after 16 it is 20. So now we have written the multiples of 3 and 4. Okay, and we can see here we are getting one common. Okay, so that is 12. Okay, so smallest common is 12. We can write here smallest common, here we are getting it is 12. So that is that smallest common which we are getting in these two multiples, in the multiples of these two digits 3 and 4s. Okay, that smallest common multiple, that will be our LCM, and which is called lowest common multiple, also least common multiple, and that is 12. Okay, so 12 is the least common multiple of the digit 3 and 4. So in this way you will find out the LCM of any two digit. We are taking one more example of a LCM, so it will be more clear to you. So we are taking an example of 5 and 5 and 2. Okay, so write the table of a 5. You can write 5, 10 and 15, after that 20. So here also write a table of a 2, 4, 6, 8, 10. Same way 12. Now here what is the smallest common multiple? Here you can clearly see we are just getting 10, the smallest common. So this 10 will be our LCM, that is called least common multiple or lowest common multiple, 10. After that we will also get 20 here. Okay, in this next on a next step you will get 20 also here and here, but 20 is not the least or not the smallest. Okay, you will only take the least, which is smallest common in both the numbers multiples. Okay, so 10 is the smallest common, so 10 will be our LCM, which is a least common multiple. So in this way we have cleared the LCM. If you still have any problem, you can comment below. So now we are just wrapping up the video. I have completed from my side whatever I can do for you. So if you don't understand anything still, you can comment. Okay, thank you very much for joining us today. So okay, see you tomorrow for next video. From tomorrow we will start our half yearly syllabus from where we left our chapter number 4th. Okay, so thank you very much. See you tomorrow.